started. Yeah.
I would like you to design a ride-hailing system.
Sorry, can you repeat that?
Ride-hailing. So ride, you could imagine it as a ride-sharing system like Uber or Lyft.
Okay. So you're doing like a ride-hailing system, right? Is that
correct?
Right. Like sharing, essentially, like you're using an application, like an app on your phone to kind of summon for a ride, right?
Correct.
Okay. So, this is more like, so I can I take like Uber as an example for this one?
Yes.
Okay. So let's talk about some functional requirements for this one. So I would say like using an app from your smartphone or like even a desktop application. Like I know Uber supports that, but I think smartphone is probably more realistic. You can request for a ride.
That is correct.
Once you get matched as a user, you want to see where your ride is, who is the driver, like car details.
You mean where your rider is?
Yeah, exactly.
Okay.
Where the car is, who the driver is, and how far. I guess where covers like how far, or maybe like how far is it? It's a different requirement actually. Like how much time it will take in time, right, and distance.
Yeah, both to come to me and also for me to arrive at the destination. So 2 ETAs.
Okay.
Yeah.
Okay. Also the ETA for destination. Okay. User should be able to cancel the ride, right?
No, let's say that for now we're not going to cover this. Okay.
Okay. So this is out of scope for now. Okay. So what else? I guess in terms of like UX, I would also like to see the price of the ride.
No, I mean, we know there is a price, but I don't want you to cover it in the system design, the price. There will be already a lot of things to talk about.
Yeah, that makes sense.
It's really detail oriented, this STEM design. So I'm going to tell you that the rider needs to be able to accept the ride as well.
Okay.
Right.
So,
or decline.
Yeah, the rider also has a logged in application. They get notification when a ride is available, right? When someone is essentially like someone is requesting, and they should be able to accept or deny, right?
Okay. And how much time do you think they will have to deny or accept?
I think 5 minutes is probably a realistic time, and after that we can the system can give up and try the next rider.
So what are the pros and cons of this of choosing 5 minutes? Think about it from the user experience perspective.
From a user experience perspective, yeah, we kind of have to like tweak the number based on the user experience. 5 minutes might be, for some user, it might be too much.
Imagine a user gets declined twice in a row. He's going to wait 10 minutes. So in practice, Uber waits between 10 and 20 seconds.
Okay.
Yeah, so the rider has to be pretty reactive.
Okay, let's say 20 and 10 to 20 seconds, but I still feel that there is a scope of optimizing this in the sense that how many riders do you have available, right? If in that area, for example, you don't have a lot of riders, you don't have a lot of scope, right?
Yeah, that's probably right.
Yeah, so there's scope of optimizing here in terms of that, I guess.
I agree.
Yeah.
I'm going to help you for the next functional requirements because they're not so obvious to see for this use case. But you know them, I'm sure you know Uber. So you know that the rider is updating the location constantly, right?
Yeah.
And the user is able to see, and I think you already wrote it. You want to see a ride in car. It's on 2.
Yeah, so like a rider should be matched based on the location. So for example, in other words, we can say that the user, sorry, okay, yeah, the user. So I'm getting confused between the rider. So rider by rider, we are referring to the let's call it a driver just to avoid confusion. Does that make sense? Okay. And when I say the user, it's actually the end user. So the user should not have to wait more than 10 minutes.
I'm not sure you can guarantee that, unfortunately, but that's fine. I'm fine with those functional requirements. You can move on to the next. Yeah, sometimes you're going to wait more than 10 minutes, unfortunately, to get your Uber. I think, as you said, it depends on the locations. I'm really curious to know what you think are the non-functional requirements for this design.
Yeah, exactly. So yeah, let's move on. I think we have enough functional requirements for this session. For non-functional requirements, we definitely want the service to be highly available. What that means is whenever the customer wants they have an internet connection and they want to book a ride, they should be able to. And the service should be available is what I'm trying to say. And at the same time, once they are matched, then they should get a continuous updates as to where their ride is, what is happening with that. Like it should not be that the service goes down in the middle of that and then they don't have any idea of who their ride is, for example, right? And where they are.
So how much in terms of availability, if you had to quantify that?
Yeah, I would say like at the minimum 5 nines.
This is fair as a minimum. That's fair.
Sorry?
As a minimum, that's fair. Yes.
Okay. Yeah. So 5 nines, that's probably like a 5 minutes downtime, right, per year. Yeah, and reliability, obviously, in the sense that if a ride is booked, then it is booked. It's not like it will be lost, right? Yeah.
Yeah, I get it. Okay.
Yeah. Okay. Let's see what else. Latency. In terms of latency, how can we define a requirement here?
Precise latency for each use case, if you're okay. Each of the non-functional requirements, give me what you think that the latency should be.
Right. I think it's more of a perceived latency here. like for example, we talked about the 10 to 20 second acceptance for the driver, right? So like from a customer point of view, when they click the button um, to request a ride, for them the end-to-end latency is the time until the time they are actually matched with the driver, right? um, uh, Under the hoods, if it's actually still trying to connect to the service, the user doesn't know about that. So like it's more of a perceived latency, I would say. um, does that make sense?
Yes, what about the other use cases? So you're saying for the match, it will depend on how much the rider, the reaction of the rider. Although you could say that maybe our experience would be that we see that the rider is selected and we just waiting for him to accept, and we can see in real time whether or not he will accept. I don't remember exactly what the user experience is on Uber.
Right,
but
right.
that could be
Right.
one of the experience, right? But
Yeah.
what about the update of the locations?
Yeah, exactly. Like the point I was trying to make was that the user doesn't know if there is a 100 millisecond, 200 millisecond delay, because it's an asynchronous communication, right? So, but yeah, let's define something on those lines. For example, if so we are talking about like eventually giving the update to the customer when the ride is booked. So within, as soon as the ride is booked, I would say like within 100 millisecond, 200 millisecond, we should communicate back to the user, and the rider location should be within 1 second delay. Does it make sense?
Okay.
Okay. So we have yeah, we have some good non-functional requirements. Anything else you want to talk about here?
Well, you need to design something scalable.
Yeah, definitely.
The data should be durable.
Durable, like I'm kind of taking that as part of the reliability.
Yes.
Yeah, but definitely scalable is a requirement. Like let's after this, like we can talk about the number of users and that kind of stuff, and it should be able to scale up to those users. Yeah. So let's move on to some estimations. That's fine. Okay. So we are talking about an application like Uber. So I'm guessing we are talking about somewhere around, I mean, 200 to 300 million users. Is that a good estimate? Can I take that estimate?
That might be the user on a yearly basis, but what about the daily active users?
Yeah.
What it would be a good approximation? Something fair. You don't need to be.
Yeah, I would say like a daily active user would be probably like 1 million mark.
Okay, let's say 10.
Okay. Yeah. And yeah, and so it's so let's estimate the um, number of active users per second. I know what I'm trying to get, where I'm trying to get with this is that there'll be a lot of users who are just there, have their applications open, but they're not requesting, but probably they are just looking for um, the updates on where their ride is, for example, right? So like we have uh, so that comes out to be 100 users, I think. Does that sound right?
How do you?
Just, yeah, it's like 10 million by, okay, no, sorry. Yeah, 24 hours and like 60 minutes and 60 seconds.
Yeah, so you have 100,000 seconds in a day, roughly. So
right. So that's like 10 to power 5, right?
yes.
So, and we're talking about 10 to power 7 here.
Yeah.
So like 100 users
Yes,
per second. Yeah.
that's good. All
Okay.
right, let's stick to the number of requests per second. During the design, if we find something we like to, and we would like to estimate the size of, for example, the database, we're gonna do it. We're gonna do it during the design,
Okay.
not during the high-level design.
Okay. So are you suggesting like moving on to the high level design?
Let's move on. I'm curious to know really quickly what do you think will be the endpoints, the API, the public APIs available?
Yeah.
Not all of them. Let's say the main one.
Yeah. Yeah. Let's go ahead. Yeah. So based on the requirements, I'm thinking like we definitely need like a request write API, which takes in like the user token, assuming that the user is authenticated. Location is definitely important, the username of the user. So based on the location, we should be pretty much able to yeah, I think that should be good enough. Yeah.
Yeah.
And then you can have like a cancel write. And then this returns like a write ID. And cancel write takes in like a write ID.
Yeah, you don't need to support cancel, right? What is the location? What will be the location in practice?
So location, we can have like longitude and latitude kind of thing.
Okay.
Yeah.
Okay.
What else? So we also want to so for the updates, I'm thinking more of like a push model, where the server actually pushes updates to the client, right? But at the same time, I want to get like an API to get write info, which gives it the right ID, and it returns you an object with like the driver name and all that kind of information that we just talked about, right?
Okay, so you want to pull this data at just in case? What is your reasoning behind that?
The reasoning behind is that, for example, if the application crashes, right, then you should still be able to come back. For example, if we persist the write ID locally on the device, then we should be once we come back, we should be able to query the status of the write.
You're talking about the client crashing?
Client, yes, yes.
Okay, well, let's talk about that during the high-level design. I'm curious how this will
Yeah, sure.
work.
Yeah, and I'm thinking about an API for like a track write kind of API, which is more like a persistent session. it creates like a persistent session so that the server can actually push information about the ride in real time.
Okay. And there would be many APIs here. Actually, the APIs, there could be 20 of them, right? So we're not going to do all of them. There is get ETA, there is accept the ride, there's a lot of them.
Yeah, yeah. I mean, like, yeah, we can have like pull versions of them. But I'm thinking like this track ride is gonna kind of push all of that information to the client in a time as a stream.
Yeah, I mean, right now I'm just caring about the public APIs, right? And so yes, you can assume that the client has some kind of way to ask the servers, hey, give me information, push me constantly informations about X or Y. Yes.
Yeah,
So
and that is this API.
okay, got it.
Okay.
So
Yeah.
I'm fine with this these requirements. We could go much deeper. I'm curious to know what you think would be the main services involved to
Yeah.
these functional requirements.
Right. Let's do that. Yeah. So I'm thinking like so let's first this is our client, which is like a mobile application, for example. Then I'm thinking like a high-level service, which the ride request service. This is more like accepting new ride requests. And we have like two type of clients essentially. One is the actual the user or the rider, the end user, and then we also have the driver. They have like the client in a different mode, right? Oops. Yeah. So driver also kind of wants to kind of communicate their kind of information, right? So I'm thinking like a dedicated service for that, which is essentially, what do we call it? Let's call it the driver management service. And I'm thinking like that we need like a database which give me a second, sorry. Just thinking a single response in a single responsibility kind of way, a service which is responsible for keeping the location for all the drivers, right? So let's see. So this is like a, or what we can do is we can have like a location service, a location management service. Now this is responsible for user location. It could be the driver or the rider, right?
Okay. Why do you want to put the rider? I mean, the user.
Yeah, I didn't cover it in the functional requirements, but I know that the Uber also shows the location for the rider
Okay.
in the application for the drivers.
All right. I will let you lay out all the services you think are relevant, and then I will
Yeah.
ask you specific questions about the workflow.
Yeah. Okay. Yeah. Yeah. Let's see. What else do I need? So I'm thinking like a client makes a ride request, and we need to match it to um, all the available drivers. Um, so so I'm thinking like this guy is also responsible for giving me keeping the metadata for the right drivers, right? What that means is that we need to know which driver is actually available, right? Um, yeah. So like a driver info. Now that I think of it, I think this probably makes more sense to it probably makes more sense to keep all the driver information here, which means I'm mostly interested in the information like is the driver logged in, um, and what is the location.
Okay.
Um, this is more like a dynamic information, and it will also have the static information for the driver in the sense like the name and all that stuff, the details about their car. Um, yeah, and let's actually get rid of this for now. I'm just rethinking this. Um, and I need a service which actually does the matching, right? So when a request comes in, we will actually go to the matching service and say, hey, this is my location. This is the location of the client, and he or she is trying to um, get a ride in this location. So find the available drivers in that location, right? Um, so that makes sense to me. But we also what and then from there on, what we have is um, we know. Let's say we get a list of the drivers, right? So this ride request service can then talk to like a notification service, um, and notify the drivers. So let's put in a block for notification service. So this guy actually just like sends like a notification to the driver, um, and the driver can response back to it. What this and this is kind of handling that the ride request service itself is handling like the um, the state management here, the flow management in the sense that if the driver does not respond within the 10-second time, go to the next driver kind of notification and cancel the previous one, right?
Okay. Can you link the components,
Yeah, yeah,
all
definitely.
of them?
Yeah, and one of
All
the
of them?
yeah,
What does the notification service do? Who does it talk to?
the notification service talks to both kind of clients. The ride request service can tell the notification service to to send a notification to the driver and say a ride is available. If the ride is available, if the driver accepts or denies it, then it will go back to the management service. And we should also have like a yeah, I'm thinking let me come back to that and just draw all these first. Yeah. Okay. Yeah, that makes sense. Yeah, I'm just thinking like how should the client communicate back to the other client, as in the drivers communicate back with an acceptance or a denial, right? Because the entrusted service here is actually the ride request service. So I'm thinking more of.
What do you mean the entrusted service is the ride request service?
So the ride request service has put in like an asynchronous kind of notification, right, for the client driver, right?
Okay.
What will happen is that the driver will get like a pop-up on the screen, and either they will accept or deny, right? What I'm thinking is that and that's why the ride request service is the entrusted service here, in the sense it is expecting a reply back, right? And this is
So that it can answer to the client?
exactly, it can match essentially, right?
But are you saying that the client is going to hang until the driver accepts?
No, this is definitely an asynchronous
Okay.
asynchronous request, and that's why I have this.
So then the ride request service doesn't care about whether the client accepted or declined. He totally does not care about this, right? Because he already said to the client, "I'm good. I put your request in my queue or whatever in the matching service." So why
Right.
does the ride request service care about? Why is he interested about the driver's updates?
Yeah, I think so. I was putting the responsibility of actually matching in the ride request service, but I think that's a good point. It makes sense to keep it in the matching service. The whole logic here. The ride request service will be mostly consist of like queues, as you said, so that you kind of decouple the client from the
So,
main logic,
so
right?
where is the arrow here that go from the client to the service and goes to the client? So sorry, how does the driver inform the client that he accepted the trip? I don't see this right now in the design. How
How,
does the driver
uh-huh.
inform the
Yeah,
user,
yeah, yeah.
I
Yeah,
accepted the trip?
I was coming to that. Yeah, yeah. So I'm thinking I'm thinking the same. Um, I need to name this better, but this is like a how do I?
We can call it a routing service.
Yeah, yeah, exactly, or like a broker kind of thing, right? A message broker, essentially.
Which technology would you like to use for this message broker? Which protocol, how is he going to work?
Yeah. So I am not familiar with many message broker protocols. One of the protocol I'm aware of is like MQTT,
No,
which
I just care about the persistent connection. Which type of persistent connection do you think would be relevant here?
right. So like if we talk about a protocol like MQTT, is just a persistent connection over TCP, pretty much. Does it make sense?
Okay.
Yeah, I mean you can use like WebSockets kind of technology as well, which is something which is something that starts with HTTP, and then it is also something that, I mean, at the end of the day, it's just TCP, right?
Okay.
TLS with TCP.
I will let you handle because there is something ringing in your computer, I think.
Oh, no,
So
that's fine. That's fine. We can ignore that.
yeah.
Sorry about that.
Okay, that's clear. What are the trade-offs between the two?
Sorry?
What are the trade-offs between the two? You said you talked about WebSocket and another technology. What would be the trade-offs between the two? Why choose one over the other?
Um, I don't see any trade-off in terms of, for example, performance. Um, let's see. I think WebSockets might make more sense because it just requires a one directional TLS authentication. If I'm not wrong, like MQTT kind of protocol will require like a mutual authentication, which is probably an overkill here. But otherwise, I don't see any like performance.
Yeah,
Yeah.
is it excluding using AMQP with web? Okay, can you do both? Can you do both AMQP and WebSocket? And does it matter? I'm more interested in trade-off between the WebSocket, log polling, and polling. Which are the three general way of having a persistent connection. Why
Mhm.
why would you use polling? Why would you use long polling? Why
Okay.
would you use
Yeah.
WebSocket?
I was not even going to polling, but I can talk
Why?
about that.
Why not polling?
Why not polling? Because I think it's an inefficient method, right? In the sense because the way polling work is that you open an HTTP connection, which is anyways an overkill, um, because you'll do like you keep on opening a connection, right? And once you get a response, that
All
will
right.
close, then you open again, right?
What about long polling?
Long polling is my understanding is based on HTTP itself, right? It's you'll start an HTTP connection and you'll just the server will not close it until the result is ready, right? Um, so you keep on doing that over and over again. So it just you're incurring the cost of the handshake every time. Whereas a persistent connection like WebSockets or the other protocol that I talked about, it's a persistent, long-lived connection. It will never be closed unless the client wants or the server drops it, right? And in that case, you just pay the cost of the initial handshake just once.
All right. So that's clear. Um,
Yeah.
so let's go deeper into the design. So the driver updates its location to the driver management service. Okay,
Right.
from my understanding. Now, I'm assuming this matching service, when it gets a request, it will somehow fetch all the drivers that are that are available and near to me, right?
Right.
How do you do that? How do
Uh,
you get the closest drivers? Let's say we have an algorithm that finds the 20 closest drivers as a first step.
right.
And the next step of the algorithm are to compare what would be the impact of choosing one driver over the other. But let's not care about that for now. Let's say our goal is to find the 20 nearest drivers, available drivers. Tell me about this data store that you've built here, how you're going to scale it, and what it's going to look like in terms of schema.
Yeah. So I'm thinking like it definitely let's see one approach. Okay, let's discuss multiple approaches. I like while discussing, I might come up with like which one is better. I'm just thinking out loud. One approach that I can think of is that you map the location to let's say a grid element in terms of longitude and latitude, right? What I mean by that is, so if you can imagine like a map and you just draw a bunch of latitudes and longitudes up to a up and the resolution you can decide like till which degree you want to draw this mesh on your map, right? If
Okay,
you
but
just
this map, it is stored on what? Can you have a schema really quickly? Yes,
yeah
let's use a table schema just for now. We don't care if it's SQL or whatever. Just I would like to see the schema you're going to use, the main fields of any table you use.
Yeah, so this is like let's say this is a location table, right? I am keeping like a driver ID, and at the same time, I am keeping the let's say original driver longitudes and the original latitude. And what I was about to say is that you kind of divide your like the complete space, location space, into grids up to a certain resolution, and then you map this original location into that grid. So you will have like grid coordinates essentially, right? And this will be like multiple entries, obviously.
And so what is the size of your grid?
The size of the grid, we will kind of decide on what area you want to like till like so for example, if the user requests a ride, where are you going to search? For example, if you want to search up to like 5 miles distance, so this grid can be like a 5 mile cross 5 mile.
I see. Okay. So imagine we are in New York. We have like in 5 miles to 5 miles, you can get maybe 300 drivers. How are you going to choose inside those 300 drivers? Which one are the closest from me? Right, because your grid is pretty big, right?
Right. But you also get like the once you query based, so you got an index on the grid coordinates. You do the same thing for the client coordinates that are coming in the matching service, and then you match it against the grids here. So you'll probably get a list of drivers, as you said, like if you get like 200, 300 drivers, but you also have the original coordinates of the driver, right?
Tell me specifically how you do this matching. Let's say you have a SQL table, you have a latitude, longitude, and you have an incoming latitude and longitude from a user. And now you need to find, okay, what is the grid where this user fits, that's inside that grid. And also, I have a problem with your grid coordinates. A grid is a square. So how is it the center of the square that you have here in your table, or is it the extremities of the square?
The extremities. Yeah, so to define like a grid, you need, for example, like the diagonal coordinates, right?
Okay, so let's say you have 4 extremities. How do you know that the incoming location matches into this grid? You could have thousands of grids.
Yeah, so I'm not going to write SQL queries. I'm not really good at that.
Yeah, no, don't write a SQL query. Just tell me how to do it in the background, right? How does that work? How to find
So I will talk about the matching service logic here. Okay. So like from the client coordinates, right? You get you get the grid vertices, for example, and there should be, and it should be the same way that you calculate the other ones, right? So they will match. And then you query this the location table, to get the list of drivers that are matching, driver IDs in this grid. There is definitely a scope of it's not a perfect solution, in the sense that a driver might be just outside the grid.
It's not a problem for me that it's imperfect. Let's say we work with that. So the client coordinates, somehow you find a way to find the which grid contains these drivers. So are you saying that this location table here has as many rows as we have drivers?
Yes.
I see driver ID. Okay,
yes.
Interesting.
Yeah.
So now I'm a driver. I am updating my location. Imagine you are the driver management service that tries to put the new location into this database. How is it going to work?
Yeah, so that's a good question. Yeah, I think the database is going to be thrashed, right? With like continuous location updates. So what we can definitely do there is like a layer between the actual persistent data store, and we can keep all this information in memory, and we don't need to flush it to the disk on every update, right? We just need to update like in memory data. Is that
but
implying?
If you reason like that, you will still have the problem at some point when you flush the data into your database. How do you find where the location is, right? If I look at all your fields, you have the driver ID, you have the original. I don't know why you call it original also. Why is it called original driver longitude? Why is it just not just driver longitude and driver latitude?
Yeah, I just wanted not to be confused with the grid. Yeah.
Okay. So imagine you're this driver management service. You have this table available to you. Let's say it's a SQL table. You are looking, you find a way. You have the driver ID, right? Do you? Okay. So based on that, are you able to do the updates? Yes or no?
Yes.
Yes. Okay. So what do you think are the problems right now with your design? If you think about all the use case, so you need to update data consistently,
right?
And you need to query into this location table. What do you think would be the problem?
The problem is that it's a lot of data to handle for a like, for example, a single database node. So we definitely need sharding here.
Okay.
Is that what you were trying to get to?
Yes. Okay. I'm interested to know about how you were going to shard.
Yeah, definitely. Yeah, and that's why I think I'd mentioned this, probably got slipped. Is that we're going to shard based on the grid coordinates. And why I'm thinking about that is because then you can also decide where that lives physically, right? So for example, if someone in San Francisco is trying to get a ride, they don't care about the database entries from New York, right? So we can probably save that closer to the physical location as well.
Okay, but then when I have to update if it's sharded by grid coordinates, how does the driver management service, how does he know where is the shard that contains my driver ID? It will have to look at all the shards to find the driver ID. You see, let's say we have a 100 shards. It's going to have to look at every one of them to find the driver ID, right?
That's that's definitely a problem. I'm just thinking which kind of queries we are trying to optimize here.
The put, you're trying to put a location into the driver info.
Right, but I'm also trying. I'm also seeing like there are also like read queries, right?
Exactly.
Service. That's the like my grid coordinate by indexing on the by indexing on the grid coordinates. We're kind of achieving like we're optimizing for that read from the matching service. But for the use case where the driver is kind of updating. I'm thinking like the driver, when they update their location, they will always have the location with that request, right? So we should know where we have to go, like which shard we have to go. The case that is interesting is when the driver switches from one location to another, and essentially like switches from one grid to another, right? In that case, we don't really know where in which grid the driver was beforehand, like before that, which makes it tricky.
So can you think a bit outside of the box? It looks like this alone, this database, this data store won't be enough. So maybe we need another data store,
like a different materialized view on top of the data store, maybe.
I don't know. You tell me what you think.
Yeah. No. Yeah. I'm definitely. Yeah. I'm thinking about that. Yeah, I think this what I have is definitely good for them. As I said, like the queries from the matching service. What we can do is we can keep a lookup between driver IDs and the shard. That way, whenever a request is coming to update the location, we know where we need to go. And if it, and while updating, if it happens that we need to change the essentially like the driver will be jumping between the shards, right, while they're moving across. So yeah, we can modify that. How does that sound?
So just write it down or explain it again. It's not exactly clear how this would work for me.
Yeah, so like a driver management service, right, can keep like a lookup from this is like a lookup between driver ID and the shard ID. And so whenever we are updating the location for the driver, we know which shard we want to go to. And then we update the location there. If it's still in that pretty much okay, so the logic would be like we look at if it's still the same grid coordinates, then we know that we just need to put it back into the same shard. Otherwise, you reshard it, essentially like recalculate the hash based on the new grid coordinates.
I see. And initially, when you update it for the first time, where do you put the shard? Where do you look for the driver? Let's say the driver just got onboarded into Uber.
Yeah, so you won't find a entry in this lookup, right?
Yeah.
So you will, but you do need you do know the grid coordinates if the driver is logging in. So based on that, we can like decide in which shard it goes, right? And then you just populate this lookup.
Okay. I, I think in theory, the design you've described here could work.
Mhm.
So could you wrap up with your overall system design, looking at the functional requirements and at the non-functional requirements, and what you would have talked about if you had more time?
Yeah, yeah. I did want to talk about like another block of service which manages the connections, but I think the message broker can be that guy, because obviously you are creating like a persistent connections with this. But to scale the message broker, we need, this cannot be just one service, right? I mean, this has to be replicated. By replicated, I mean, sorry, replicated is not the right word. This has to be horizontally scaled, right? Yeah, so I did want to talk about that. I would have touched on that. Let's go back to the functional requirements for a second. So we talked about the user making a request, right? And then it goes through a matching algorithm, which can communicate to the client, a client or the driver, and get the response from the driver. And this matching service is actually like subscribing to that as well. So that's how it knows that the matching is successful, right? And now it needs to communicate to the rider that is successful, right? So it can still use the message broker for that. This is the arrow for that. So for a successful connection, right? We do need like a persistence to kind of hold that state. I think that's something missing, to hold the state of matched rights, right? Um,
Okay.
and then what we also, okay, let's go back to the so functional requirement. I think one is covered. The second requirement is about that you should be getting like continuous updates about the driver. I think that piece is not covered in my design, because
Well, you mentioned that the client would send to the message broker the updated location, but you can assume that this message broker is just a persistent connection. It should not handle any logic, right?
yeah,
So
exactly.
that's what was bothering me, is that this
Yeah,
message broker.
it is not handling any logic.
Okay, so yeah, I guess there is another server that takes care of updating.
Exactly,
Okay.
exactly. This arrow was just for like the response back when the client accepts or denies, because that can be achieved through like a queue in the message broker, right? Which the message service is subscribing to. But we do need like another service which handles the um, um, I'm thinking what to call it, whether this is more like a call it the right status service. So this is the guy that is actually um, this is gonna subscribe to the message broker for updates from driver, right? And this also needs to know about the rights that are matched. and it communicates back to the message broker for any updates, which the client can subscribe to.
Hey folks, thanks a lot for the great discussion. Unfortunately, we are running out of time. So we have already taken about 55 minutes. So I think it's a great time to wrap up and maybe start providing some feedback. What do you guys think?
Yeah, let's go.
Yeah.
So I really enjoyed how you detailed and you asked me questions at the beginning about the functional requirements. There are a lot of functional requirements in this system design. I voluntarily wanted to do a lot of them to see how you would perform.
Mm-hmm.
And you did decently well. I think for the driver information, it is really hard and really easy to fall into the trap of using a quad tree, right? If you've heard of them. So the fact that you did not use them, I think, is a good thing.
Yeah, I know
been...
that there are geo like databases specially optimized for locations, but I haven't really read about them. Yeah, so I was just coming up something on the fly.
Yes, it's also a good thing that you realized that the notification service was not enough, and it could not only push, but it had also to receive, right? And so it had to be more than just a notification service that push. Also, your non-functional requirements are, I think, exhaustive, except the scalability that was missing, but usually it's pretty obvious.
Mm-hmm.
And for the estimations, I voluntarily made them short. Same for the API. I think it's easy to fall to have too many to take too much time into the APIs, and I think I would have loved to talk about the track ride here that you wanted to implement, because you seemed to assume that the track, for me, it's not something that the client does. Like for me, when the client starts the ride request service, it's the ride request service that's going to take care of, or when you log in, something is going to take care of creating a persistent connection for you, right?
Okay. Yeah. Yeah. The way I was thinking about it was, the client can initiate that connection, like another connection, right? Because this is going to be, this call is going to be like a HTTP request response kind of thing. And then you need another connection, a dedicated connection for persistence, like a persistent connection. So client can call like track ride to initiate that. And then it can be HTTP, which is later upgraded to WebSocket, for example, or it could be just directly talking to the message broker.
I see. Also, we did not talk too much about the matching. It would have been nice to talk about that, just the algorithm, what you optimize for this matching.
Mm-hmm.
And yes, it would have been good also if you had identified immediately the limitations of the database that you built, and the fact that you needed another data store or something else to be able to both be able to update and read.
Yeah.
But you reacted pretty well to the conflict that your design had.
Mm-hmm.
So overall, that's my feedback.
Thank you, and thanks a lot for interviewing. It was
Thank you.
I enjoyed it a lot as well. Thank you. Anyone else has any feedback? This is the first time I was doing such kind of mock interview, so I can use any feedback that comes my way.
So I guess let's talk about the his system. If you have any feedback on the system he built.
Oh, is this a question for me?
No, I'm asking questions to everyone here in the group. If you have anything about the system that you would like to say.
Yeah, so yeah, this is not feedback. This is something I'd like to learn as well. So what's the best way to actually ensure that both writing location information and reading location information is actually performant? So let's say if we use sharding based on driver ID, it's going to be hard to actually do the read query. In the other case, it's going to be hard to do the write query, right? So what is the best way of doing this in terms of storage and updating user location? Have you read anything about this?
Yes, so I guess I could try and answer unless someone has something to say. So spontaneously, I think the interviewee here did something that makes sense, right? Using two data stores and driver ID maps to shard ID. In practice, there is another way to do it, which is having a table where each grid is a key in this table, in this hash table, for example. And this key maps to a list of drivers. And so this would be in memory, in Redis, for example.
Mm-hmm.
Then this allows to perform the queries pretty fast, right? Because you can fetch the drivers in this grid. And then after that, you can eliminate the excess amount of drivers. Let's say if in your grid you have 300, but you only want 20, you can eliminate them just by hand because it's only 300. It's not computationally expensive. Now, what about the update? Well, you need another table. And it looks similar to what he built, I think. That's a decent design, right, what he built. And there we need the driver ID, its position, and we also need to tell our interviewer a logic for how we're going to switch grids, right? Because now when we update into this table, what's going to happen? The grid could change. And so we have to change this cache that we built, right? And to invalidate it.
Yeah.
So to achieve this, we can either do it synchronously or asynchronously. And there are pros and cons to both.
Okay.
But overall, that's the...
Okay.
So originally I was thinking about like keeping a secondary index on the grid coordinates. That would have...
Here's the thing, though.
Achieved the same thing, right?
Yeah, here's the thing. It's we have the same problem. If we have multiple shards, that becomes an issue because you don't know to which shard query. But there is something that you could have said, which is that, what do you mean there is multiple shards? I know what I'm querying. I'm querying New York, and I'm sharding by grid coordinates, right? So I know where my shard is. So what's the problem with this thinking, right? Because you could reason like I could say, well, I know where my shard is because I'm querying New York, and I just sharded by grid location.
Yeah, I think but I fell into that. Yeah, that because as I talked about that scenario where the driver switches city, for example, in that case, or the grid or the grid. So you do need.
I think there is that. There is switching shard, then becomes a problem, right? Because even if you're querying New York, what happens if you're between shards, right? That's not really a common use case, to be frank, right? Not many people they are making a Uber request between New York and New Jersey, for example. But they could, right? And then you have this problem where you either you ask the two shards that are close from each other, from that person, to find the drivers, or you're choosing one shard, but which one to choose. So yes, that's the downside of this method. If anyone has something to say about this also. Okay, well, I don't know much about New York and New Jersey. Yeah, someone just mentioned that he was doing New York, New Jersey many times. Yeah, what I meant was just New York and another city far from it, which are to use. But if anyone has something to provide about this discussion, that would be great.
Um, so I wanted to understand the update of the location. So when the writer sends the request, right, and the matching service is the one who is like doing the matching of the drivers, but the driver location is also changing, right, at the same time. So how that will work? Like, do we take at that particular point of time where the driver is, and then based on that we do the matching? But if that's the case, then the data can be stale, right? The driver can move to some other place while we did the matching, and then we pick the wrong driver. Does that happen? Like, how do we do it?
Yeah. Again, if anyone wants to say something.
I can just talk about how this design takes care of it, but if you're asking how Uber does it, I'm not sure.
Okay. Yeah.
And yeah, the reason for taking grid coordinates was the same, is that you have a buffer, right? If you have, even if you have data which is stale by few seconds or minutes, you can still assume that the driver was in this last known grid coordinates, right? So you have some buffer there. But obviously, if yeah, that's a good point in the sense that we can keep like a last updated timestamp. And based on that, we can filter out some stale entries.
Yeah,
Yeah.
I'm going to answer you what I would answer in an interviewer if I had the problem. I would say, so I would use the design I just described before with a hash table with the grids that maps to a driver. So then I'm going to tell my interviewer, hey, I'm updating a location. So I'm updating my table with the driver information synchronously. I'm updating this. Perfect. Now, when I'm querying, I'm looking at the grid, my other hash table. This grid is going to select all the drivers. I fetch it into the driver management service that you see here. The driver management service takes the N closest from this list. Okay, and that's not computationally expensive because we've already filtered out a lot of candidates. And from those ends, we query again the driver table to find the information. We make sure that the driver tables and the grid tables are scaled properly and with caching as well. And we are able to perform this query pretty fast. So to answer just long story short is we get the grid, we get the drivers, we filter them, and then we get the driver informations and nothing is stale.
So yeah, thanks for the explanation. So I have follow-up questions. So when you say table, are you talking about the in-memory caching, or is it in the database, all the things in the disk?
So I'm suggesting, for example, Redis would use so in memory Redis or a memcache for the grid. So the grid latitude and longitude, for example, could be the key, or it could be the center of the grid as well. And it maps to an array of, it would map to an array of driver IDs with their respective location as well.
So I have follow-up question on that. So what about like a radius? Like I want to search within some radius, right? How that will look like?
Yeah, so there is a problem with radius. It's that if you are, it could be in between multiple grids, right?
Yeah.
So in practice, Uber, they use S2. But the thing is, I'm not able personally to explain it clearly to my interviewer. So usually I would just say Uber uses S2, and then I will proceed to design this simpler approach.
Okay.
Right. So, but S2 takes care of that, right? Using Hilbert curves and hexagonal tiling.
Mhm. Yeah, yeah.
That's pretty complex. Now, in practice, with this simple design, what you can do is query multiple grids. And then the radius will be taken care of by the driver management service. The driver management service could do could search in the radius having a certain amount of points, a certain amount of drivers. By the way, I made a mistake. I said the driver location would be in the grid. It can't be, right? Because it's stale. So you have to have the driver IDs, which means that if you look at my workflow previously, a user fetches a grid, and then you have, let's say, 300 drivers into this grid, where you are actually forced to ask your database, hey, give me the driver information of these 300 people, and make the radius based on that. Again, this is in this simple design where we use the grid location, etc., instead of using Google S2.
Okay. Cool. Cool. Sounds good. Thank you.
Yeah. I have a question. So how are you deciding the grid? Like, is it based on some miles or is it based on number of drivers? Like how you are dividing the different grids? Like I understand you like each grid will contain different drivers, but how you are making like the grid table?
Yeah, this is the limit of this design using grids. Currently, I'm learning more about S2 and how I would be able to explain it, but S2 will be able to dynamically update the grids. But here our grids are static. You could say that we could find a way to make it dynamic based on, yes, the number of drivers, because the more drivers we have, the more computationally expensive it's going to be with this design. So we don't want many drivers in the grid, but not too little, right? Just the right amount. And that's what I would say. I would say that these grids have to be chosen carefully.
Yeah, I was thinking like you have like a statically sized grid, which you can obviously tweak. But as you said, like based on how many drivers you find in that grid, you can even expand your search. Like the matching service can even expand the search and look at nearby grids, right? But it can start with like a 5x5 kind of search space, then expand.
Yes, I see. Anyone has something to say about Google S2 and how they use this to solve this problem? If anyone wants to share. Never mind. I was curious, maybe there was someone that knew it in the chat.
Yeah, I believe they have a fixed grid, a grid size. So all the map is converted into the grid from before only. So you don't have to worry about like dynamically creating the grid ID and all. That's what I think they have, and uh, I can come up. I can answer the questions later. Like if you have more, I read about S2 long time back, so I can. My memory is fuzzy right now.
Great.
I have a question about the you talked about like you talked about 3 approaches for persistent connections, long polling, and then a plain persistent connection over TCP kind of thing. What was the third one that you talked about?
The long polling, WebSockets is usually 3 differences. Most of the time we exclude immediately polling, right?
Polling is
then
by polling you mean like request response continuously?
Yeah, most of the time we exclude it. So oftentimes it's a trade-off between long polling and WebSocket. Yes.
Right. Okay.
So I have one question here for so you said the client, the driver client will be talking to and fro from message broker, right? And message broker is the one who will be sending the status update to rider as well. So are we talking about the same message broker, or are we talking about two different message brokers here?
This could be the same message broker, but this needs to be scaled, like horizontally scaled. Um, it could be the same message broker, and you could create the but you will have like different topics that you're publishing and subscribing to, definitely, right?
Hmm.
And those topics can be on different broker instances, I would say, if we are sharding on the topic, for example. Does it
Okay.
make sense?
Yeah. So I have another question. You said for the driver management service, it will keep the information like driver info, who is logged in and location. Why do you want to keep the logged in status there?
Why do I want to keep that?
Yeah.
Uh,
Shouldn't this is responsibility of the client if the client is active, right?
mhm.
Um, Client for the driver is active, then you know the driver is logged in. Why do you need to keep that logged in information in their your in-memory cache or whatever you have there?
Yeah, so from the initial thought I had when I was putting this block here in the diagram was that I need to know the drivers that are available to um, to accept or deny the request. So I would filter on that. But I also like the idea of keeping the last logged in timestamp, for example, the last reported timestamp, and we can based on that we can um, decide like if this information that we have is stale or not. I see that the logged in might not be a very reliable information because the connection between the driver and the service can be very intermittent. Could be like a 3G, 2G, LTE kind of connection, right?
Mhm.
So yeah, we cannot keep like a consistent state for logged in. I think like timestamp is probably like a better.
Mhm. Mhm. Okay. Yeah. So I have one feedback for you. I like the overall flow for the interview. I like how you defined the function requirement and non-function requirement and went through API and the design. So the one thing which was missing is from the error state, like what happens if the driver drops in middle. How will you make sure the matching service is able to pick up the next driver? That one was missing, and as the interviewer said, like matching service in detail was missing from the discussion.
Mhm.
um yeah, I think those were the 2 points I would like to call out.
Yeah, I think that's a big piece that I missed. I think in terms of yeah, if the driver cancels in the middle or uh, becomes like unreachable, for example. Yeah, we need someone to track that continuously.
Mhm. Similar with the rider as well, like you don't want driver to go to place where rider is not available anymore or something like that.
Usually, I've seen Uber not do that. Like even if your mobile turns off, right, the driver will come to you. Um, but if the driver explicitly, sorry, if the rider explicitly cancels, then yes, definitely we need
Mhm.
to we need to take that out of the
Mhm.
this DB that we have here and communicate back to the driver.
Mhm, mhm.
Yeah, I had written what feedback I forgot to tell you. If you are asked the question, mention a lot of queues and streams architecture, because they in practice they use a lot of that. We don't see it right now because you've done basically the high level design, and we've talked about low level on the driver management service. But on the other services, it's a lot of streams and queues and Kafka and all of that, because you have a lot of consumers, not only just for the functional requirements we have, but for all the others.
Yeah.
Now, in practice, you could imagine that when you do your design, you can detail even more and say that the ride request service does not directly talk to the matching service, but it pushes to a queue, which is then consumed by the matching service. It's a detail, like I know that you probably thought of that because you said it was asynchronous, so you probably thought there's probably a queue somewhere, but it doesn't hurt to talk about that.
Makes sense. Yeah.
Yeah, also one more thing I remembered. So I think you should have mentioned that as well, that the driver, when you are filtering the driver, you can filter based on the who is closest to you, and maybe who has more ratings or more reviews. You can just talk about that, just to have a thought process that you are thinking from the future perspective as well.
Yeah. My idea was essentially to get that information to the matching service, and matching service does that
Mhm.
logic of ranking essentially. Yeah, I
Mm.
could not do that, but I also like the idea of doing some kind of filtering beforehand, even when you query the database, and then give that information to the matching service. Like there can be like a balance there. I
Mhm.
see.
Yeah, and I think when you are describing the table, like you didn't mention about what does it contain. The interviewer had to ask you. So I will say either you can mention I will come to that later, or just start talking about it, or depends on the interviewer as well. But if you just mention that, maybe if you think that you are running out of time, that I will come to uh, um, at this, like what does it contain later, maybe, or if the interviewer is interested, he will be able to like go into detail.
You're talking about the location table here, or like my
I'll,
this table?
yeah, both of them, like interviewer had asked you and then you started writing down.
Oh, I see. Okay. Yeah.
Yeah.
Makes sense.
Overall very good. I really liked it. Yeah, thank you.
Thank you. Okay. I think it's it's over 9 here in Pacific. I think we can wrap up. I have one request. Whoever is gonna host this video on YouTube,